here we have a straight wire, and the total length of this straight wire is divided by this 6.50 meter, and at one edge here this is located at the negative 4.00 meter, and another edge here is located at 2.50 meter from the origin. Let's say this is the origin, and until here this is a point P, and this is the x-axis. Now the distance from this here to here, the horizontal distance, is given by x, and if you take the dy here, you can see until this point, let's say this is r, and they will produce electric field dE. But of course you can see this, the part below this y, below the y equals 0 is more than the part above it. So you can see actually the electric field will going somewhere like this. I mean the total electric field. So we can separate it into the EY, and of course this EX. So this is E. This is the two things we want to find out in this part A. So part A, we first start with the EX, which is 1 over 4 pi epsilon, and this let's say this part is this L low, and this part here is given by L max, and so the range of integration is given by this L low and L max, and we have a dq over r square and cos theta. Now the charge density lambda is given by dq per dy, so dq will equals to this lambda dy. So we directly substitute here, we get lambda dy. Now r square will just equals to this x square plus let's define here to here, uh, here to here to by, and so we have y square. Now cos theta will just equal to the adjacent, which is x, over this hypotenuse, which is the r. So from here it makes, from here you can see this is a lambda x dy, and this is x squared plus y squared 3 over 2, right? Now to perform this integration, we were going to use the tangent theta is equals to this y over x. So y will equals to the x tangent theta. So dy will equals to the x sec square theta d theta. Now we complete our substitution. Now we change this dy into this d theta. That means the range, or say this limit, we have to change, which is given by theta, let's say theta 2, is equals to the arc tangent. This is L max, and this is x, and delta 1 for the lower limit, we get this tangent delta L low, and this is still x. So we can define like this delta 2, and this lambda is constant, we can put out. Now x is also a constant, so dy will just equals to this x sec square delta d delta. But now this x square plus y square is given by here, y is given by here, so we square it, we get x square tangent delta square, and 3 over 2 epsilon. Now we can take this x from the bracket out from the denominator. So here we get x cube 1 plus tangent square delta. This is 3 over 2. You can see here when we put out here, they still have a power of 3 over 2, and this square can be cancelled out with a 1 over 3, so the remaining is only this 3. I mean this 2 can be cancelled out with the 1 over 2, so the remaining is 3. So here we have x epsilon. This is here you see we can cancel out this with this 2, so remaining the 1x in the denominator, delta 1 and delta 2, and again this is given by a set square delta. So from here we get s square delta over the set cube delta. So this thing can be cancelled. Delta 2 delta 1. You can see until now this is just given by a cos delta d delta, right? So x, and this is we get sine delta, this is delta 2 and delta 1. So in sine delta we will just get the opposite over the hypotenuse. Our opposite is y, and the hypotenuse is just r, so this is a square root of x squared plus y squared, and the limit will change back, which given by the L low and this L max. Now from here we will get this is lambda pi epsilon x and y and x squared plus y squared, and actually this L maximum it just equals to this 2.50 meter. So we can write down here this is 2.50, and the L low here is actually refer to this negative 4.0 meter. So negative 4.0. Now x squared plus this is a minus zero. We have a square root of x squared plus 4 Now we need a rest of this parameter, which is should be given in this in the question here. We have a Q 3.15 microcoulombs, and we have a X. This is a 0.250 meter. So first thing we solve for this lambda q over this whole length L. Now 3.15 10 to the minus 6, and the length is 6.5. 6.5. So I get 4.46 10 to the negative 7 coulombs per meter. Let me put here so now we already have the all the value we want. Now x is 0.50 negative square plus so let's calculate the value. I get this is 34739 Newton per coulombs. So your this is a 3.4740 10 to the 4 Newton per coulombs, and this is only the for the x component. Now we still have to solve for the y component. So from here, mm, this is y, and this is given by the basically the same thing, minus. The reason we have to find out, we have to put the minus here is because at the first place here, right, the reference we use is pointing downward, but you will find out the finally the answer will give us the positive because we also consider the negative here. That means we will get the correct answer. Pi epsilon naught, and this is integrate is dq r square sine theta, and I think I don't need to go through the same process, so I will directly substitute all the things inside. So this is lambda dy, and this is x squared plus y squared, and sine theta will just equals to this opposite, and the hypotenuse, which is x squared plus y squared, 14 squared. This is r, and the limit is the same. This L low and this L mix. So 3/2. This is L mix dy. So for this, we were going to use the integration. So let's u equals to this x squared plus y squared. So u equals to, so du will equals to this 2y dy. So 1 over du equals to y dy. And you can see this part is being u, and this part will be this 1 over 2 du. Now, how about the limit? The limit, you can see this is u is given by here. We just substitute this correspond L inside the y. So epsilon. So we get x squared plus L max, and this have a square because the y also have a square, plus L low square. Now lambda we put out because this is a constant. Now dy were given by 1 over 2 du, and here we just given u and 3 over 2. So if you perform this integration, let's put 1 over 2 out, and you will get this is this is 1 over u and 1 over 2, and here we will get the 2, and they have a negative because this is in the denominator, and x squared plus square. So these two can be cancelled out, and this negative negative we will get the positive pi epsilon. So we change it back in terms of y, we get square root of x square plus y square L max and this L low for epsilon, and here we substitute inside, we will get 1 over x square plus L max square and minus 1 over x square plus L low square, and now we have all the value, right? First thing we find out this charge density. From here we already find out this is a 4.846, 4.846 10 to the negative 7, and 4 pi this 8.85 10 to the negative 12. Now 1 over our x is given by 0.25, 0.25 square, and L max is 2.5, 2.5 square, and minus 1 over square root 0.25 square, and plus L low is negative 4. So let's calculate the answer. So I get this is equals to 647 0.1 Newton per coulomb. So let's calculate the magnitude. This is ex squared plus ey squared, and this ex, we have this value, this square plus 6 square. So I guess this is 3.47 uh, 5 10 to the 4 Newton per coulombs. Now this whole thing is actually part A. So we want to find out this B for now. This is B, and we have a E equals to lambda 2 pi epsilon not x. Uh, so let's say this is ET, not to confuse with the B lambda pi epsilon x. So 2 pi 5 10 to the negative, and our x is 0.250. So 3.486 10 to the 4 Newton per coulombs. So now you want to find out Ex minus E over the E. So this is equals to this Ex over E minus 1. So 4 is 3.416 minus 1. Uh, this gives us this negative 3.44 10 to the negative 3. Now we also want to find out this Ey over E. This is 7.1 over hmm, I get 0.01 at 6. And here actually this formula, if you remember, this is for the infinite line of the charge, which for the charges wire case. And that means you can see here this ratio actually is referred to the percentage difference. You can see we compare this from this finite wire. If this x is much less than this the L, this is the result we get And the reason here is because most of the part will still contribute in the EX. So you can see the percentage is different is so low. This is a good approximation even you use the formula for the infinite line of charge. And you can see this EY component only give by, by this 0.0186 of this E. That means this is small enough to be negligible, and so this is a good approximation even if you use this infinite line of charge. So I think this is the yeah I think this is the answer for this whole question.